Okay, I just finished the segment addition postulate. I did notice that I forgot some stuff. And that would be dealing with, if you go back to this example that I just finished, I did not talk about the relationship of if this were W, M, and B, for example. I did not talk about what special relationship M has in relation to the whole segment. In this case, it would be a midpoint. And the definition of midpoint, it is a point that divides the segment into two congruent segments. So if they are congruent, that means they are also equal. So if they are equal, I can set them equal to each other. So if I know that S is the midpoint, of RT, I'm going to draw a diagram to go with that. So if S is the midpoint, I already know that these two segments have to be congruent. And I know that RS is 7x minus 3 and ST is 3x plus 1. So if they are congruent, that means they are equal. If they are equal, then I can set them equal to each other. Do your algebra, subtract 3x on both sides, add 3 to both sides, so x has to equal 1. So depending on what I was looking for, I would plug in RS, oopsie, I'd plug in the 1 in for the RS, so 7 times 1 is 7, minus 3 is 4. ST, if I plug in a 1, that gives me 3 times 1, which is 3, plus 1, and that gives me 4. And the entire segment length would be 8. There's another way of looking at midpoint, and that is with the segment bisector. We'll go on to another page. A segment bisector essentially does the same thing as a midpoint, but it's not a point necessarily. It can be other geometric figures. It can be a point, line, ray, or segment that intersects a segment at its midpoint. And I'm going to abbreviate midpoint. So I have a segment, and if I know that D is the midpoint, then this could be a ray that is the bisector. It could be a line that is a bisector. It could be another segment that is a bisector. So I could say that line L in this situation bisects AF. Then AD has to be equal to, congruent to DF. So again, L is the segment bisector.